All right, we're looking at topic 8.6 notes today. Don't forget you do have a quiz tomorrow and a test coming up on Thursday and Friday. We're going to do some more solving of right triangles today. And here we go with the notes. Okay, so as I said just a minute ago, we've got sine is opposite over adjacent, or I'm sorry, opposite over hypotenuse. Cosine's adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, and that helps us to be able to find side lengths, measures of side lengths. But today we're going to add to that and use these trig functions to find angle measures. Okay, so follow with me for just a second. Okay, this is a little bit off topic, but I want to make a point here. If I have 6x equal to 30, how would you solve that? Good, you divide by 6, right? Why divide? Because we need to get rid of the 6, right? So right now we've got 6 times x, and to undo that multiplication, we divide. Okay, so multiplication and division undo each other, or they are what we call inverses of each other. Okay, as are addition and subtraction. Those are inverse operations of each other. So when I'm working with sine, cosine, and tangent have inverse operations. Okay, and so what I want you to kind of think about here as we look at these, if I've got sine of x, let's say I want to solve for that angle of x. Okay, I want to get rid of the sine. You agree with that? So what I can do to get rid of sine is just do sine's inverse. And that little -1 with the sign is just notation. It's just saying that's sine's inverse, okay? Now what I do to one side, I have to do to the other. So I've got to put sine inverse on the other side as well. And what's nice about that is just like the multiplication and division undid each other, the sine inverse and the sine undo each other and kind of cancel each other out, leaving us only with x. And then on the other side, I have sine inverse is opposite over hypotenuse. Okay, so that's kind of the reasoning behind what we're doing right here. To find the angle measures, we're doing the inverse sine of opposite over hypotenuse, or we could also use the inverse cosine as well, or the inverse tangent based on what information that we do have. Okay, so let's work an example to kind of practice with this. So first things first, please make sure your calculator is in degree mode. Again, from Friday, if you do not remember to put it in degree mode, you will have mistakes on this. Okay? So in example 1, we're asked to find all of the unknown measures. Okay, so that means all of the side lengths, all of the angles. So I would start this problem by finding the remaining side length. We already know what segment AB is. We already know what segment BC is. Let's find out what segment AC is. How? How would you like to find that? Pythagorean theorem, excellent. So we're going to do 84 squared plus 100 squared, and that's going to equal segment AC squared. So when you type that in the calculator, tell me what you get. I got around 130.599, and then what are the units? Feet. Okay, so now because we just did that, we've got now all 3 side lengths. Okay, so now we've just got to focus on the angles. So keep in mind, a minute ago when we looked at our first page of notes, how did we find angles? What did we use? The inverse functions. Okay, so to find the side lengths, we use sine, cosine, and tangent. To find angles, anytime you're finding angles, you need to recognize that you're going to use the inverse functions. Okay, so keep that in mind as we continue on here. Because in this example, now we're asked to find these other angles. Let's start with angle A. Okay, if I'm working with angle A, the 100 is going to be the opposite side length. The 84 is going to be the adjacent side length, and obviously the AC is going to be the hypotenuse. Okay, you with me so far? Okay, so if I'm looking for angle A, it's a really good idea to go ahead and use the 2 segments we're given. They're much nicer to work with than using that decimal answer that we just got. Okay, so use the ones that are already nice and pretty for us there. So that means we're going to be using opposite and adjacent. Okay, so what, very good, TOA. So what trig function? Tangent. Now what are we finding again? The angle. So I'm not using tangent, I'm using tangent's inverse. Okay, so we do the inverse tangent of And it's just like it was with tangent. It's opposite over adjacent, so 100 over 84. And we can type that into the calculator. Okay. The inverse tangent, and again, don't forget to please remember to put your calculator in degree mode. So that's the first thing I'm going to do here. Remember, you go to mode, scroll down, and then highlight degree and hit enter. Okay. In inverse tangent, you have to hit the second button. So that blue button up at the top left, and then you just hit tangent. The tangent button will give you tangent inverse. Okay, and then we type in our numbers. So 100 divided by 84. Close those parentheses and hit enter. And we are asked to round to the nearest degree here, so what's our answer going to be? 50 degrees. Okay, and that was the measure of angle A. Now, if you wanted to, you could certainly use your trig functions to help you find the measure of angle C, but what's probably an easier way to do that? Yeah, do 180 minus our two angles that we have, so 50 plus 90, and what do you end up getting for the measure of angle C? 40. Make sure you put 40 degrees, measure of angle C. Okay. So what types of trig functions do we use when we're finding angle measures? The inverse trig functions. What do we use the regular trig functions for? Finding side lengths, okay? All right, so y'all are so smart, we're going to skip example 2 and go on to example 3. Okay, since there's not an example 2, you're not really missing out on a problem there. You're welcome. Example 3, here we go. Find the unknown measures. Okay, so again, same kind of thing we're doing in the first example here. We want to find all of the side lengths. We want to find all of the angles. Okay, so let's start here. How would you like to start this problem? You want to do Pythagorean theorem? Okay, perfect. So we can do Pythagorean theorem. We've got 5 squared plus segment ST squared equals 5.7 squared. Okay. So when you type that in the calculator, you should get a value for ST. What'd you get? Good, 2.737. Are there units on this problem? Nope, so we don't have to list any. Perfect. You do want to watch for those units. All right, so now we have all three of our side lengths. Which angle would you like to find? You want to find R? Okay. So here we go. Here's angle R. 5 is going to be the adjacent side length. 5.7 is going to be the hypotenuse. And obviously ST, not that it really matters, but we'll go ahead and label it for fun here. That's going to be the opposite side length. Okay. So if I'm setting up an equation here, what two side lengths am I going to use? The adjacent side and the hypotenuse. So that indicates that we're using which trig function? Cosine, okay? Are we using the regular cosine or are we going to use tangent? Or I'm sorry, inverse cosine. Why inverse cosine? Because we're finding the angle measure. So inverse cosine of what? Our adjacent side length of 5, good, over our hypotenuse of 5.7, excellent. And when you type that in the calculator, okay, and you round that to the nearest degree, what do you get? 29 degrees, perfect. And that was the measure of angle R. So help me find the measure of angle T. We're going to do 180 minus our two angles added together, so 90 plus 29. And what does that give me for the third angle measure? 61 degrees, perfect, and that's the measure of angle T. All right, continuing on, example 4. Need just a minute longer? Go ahead. Okay, so example 4. All right, we're asked to find the unknown measures. So again, we're looking for all of our side lengths and all of our angle measures. Where would you like to start this problem? You want to find the other angle? Okay. So 90 plus 58, subtract that from 180, and you should get what? 32 degrees. Good, and that's going to be the measure of angle D. Excellent. All right, so now we can find some of the side lengths, right? So this one's a little bit different, right? We found all the angles first on this problem, whereas on the previous problems we had found all the side lengths, so keep that in mind, okay? Okay, so which angle would y'all like to use? The 58, okay. So that means that the 14 is going to be opposite, EF is going to be adjacent, and DF is going to be the hypotenuse. Okay, now I'm going to go ahead and just label this. Let's call EF our X and DF our Y, just so we can have a way to be able to reference those two side lengths. Okay, so do y'all want to find the X or the Y first? You want to find X first. Okay, so that means we're going to have to use the adjacent side length. What other side length do I have to use? Opposite, which means we are going to be using the tangent. Very good. Do I use tangent or inverse tangent? Why do I use the regular tangent here? We're finding a side length this time. Very good. So we're going to do tangent of our angle, which in this case we chose to use 58. So tangent of 58 is equal to opposite over adjacent, so 14 over x. Put that over 1 and cross multiply. So you should get 1 times 14 is 14, and then tangent of 58 times x is going to be x tangent of 58. Okay, just like we did on Friday. Remember, tangent of 58 is just a number. Okay, so to get rid of a number times x, I'm just going to divide by that number. So I'm dividing by that tangent of 58. So you get x equal to 14 over the tangent of 58. Somebody type that in for me. What'd you get? 8.748. Are there units? Nope. So that's segment EF. All right, now let's find the other side length. We're going to find y this time. Okay, that means we're going to have to use hypotenuse. What other side length should I use? The opposite. Very good. Make it easy on yourself and use those whole numbers, okay? So we're going to use the sine function. Good. So sine of our angle of 58 equals what? Good. 14 over y. Excellent. Put that over 1 and cross multiply. And you get 14 is equal to y times the sine of 58. And just like we've done on the past few problems, we're going to divide by that sine of 58. So you get y equals 14 over the sine of 58. When you type that in the calculator, what do you get? 16.508. And again, there are not units specified here, so we don't have to worry about that. And we have our final answer. So we've gotten all 3 of our side lengths, all 3 of our angles. All right, last page, right? 3 more examples. Number 5. All right, if a 12-foot ladder was placed against a wall, so we've got our 12-foot ladder, what is the ladder going to represent in our triangle? That's going to be the hypotenuse. Very good. 9 times out of 10, that's going to be true because a ladder is usually going to be that diagonal or that leaning line. So that's a 12-foot ladder is placed against a wall so that the base of the ladder, so here's the base of the ladder, there's the bottom of the ladder, is 4 feet from the wall. So here's the wall, here's the base of the ladder, so I know this bottom portion has to be 4 feet. Okay? We're asked how high up the building it would reach. Okay, how high up would the ladder reach? This is what we're looking for. Okay, so walk me through how to find that value. Good, Pythagorean theorem. So 4 squared plus x squared is equal to 12 squared. So what do you end up getting for x? I got 11.314 when you round. 314, and then what are the units? feet. Good. All right, so we found our other side length. Then it says, and what angle will the ladder make with the ground? Okay, so here's the ladder. Here's the ground. So we're looking for this angle measure. Now I want to use some notation here. This guy, it's like a circle with a line through it, that's called theta. Okay, we usually use X, Y, Z to label side lengths. We usually use Greek letters to label angles. Okay, so get comfortable with that. You're going to see that quite a bit. This is just theta. It is just like me saying that angle is X, or put another variable there. Okay, that's all it is. Okay, it's naming the angle. All right, so we're going to talk about naming, finding theta. Okay, so if that's theta, what two side lengths should we use? The hypotenuse, okay, so the 12, and the adjacent side length, so the 4. Okay, do you agree with that? So what type of function should I be using then? Ah, very good. Inverse cosine. Why again the inverse cosine? We're finding an angle right now, okay? So you've got to use the inverse function to be able to do that. And it's going to be adjacent over hypotenuse, so 4 over 12. And when you type that in the calculator, what do you end up getting? Okay, and go ahead and round that to the nearest degree, and what do you get? 71 degrees. Good. All right, now the picture on the next example is a little difficult, so let's all make sure we're on example 6. Okay, it says a telephone pole broke 4 feet from the bottom. So here's the bottom of the telephone pole. It broke 4 feet up. So here we go, the pole's broken, and it fell over. Okay? Y'all picture that? Okay, so it broke 4 feet from the bottom. You've got to think about how to write this. It broke 4 feet from the bottom. So here's the bottom, 4 feet above that is where it broke off. Okay, it says that the top of the pole landed 3 feet from the base of the pole. So here's the base of the pole, here's the top of the pole. So we know that's going to have to be 3 feet. How tall was the pole originally? Okay, so in order to be able to tell how tall the pole was originally, I've got to find that hypotenuse. Do you agree? Anybody see what it is already? Ah, you could use Pythagorean theorem. It is a 3, 4, 5 triangle. I've got side length of 3, side length of 4, so this has to be 5. You can do Pythagorean theorem if you don't see that, okay? So, if I'm thinking about how tall the pole was originally, I've got to take this 4, and what do I have to add to that? The 5. So the pole was 9 feet. Very good. Okay. Now looking at the next part, okay, it says what angle did the top of, y'all pretend like that says pole, okay? The top of the pole, okay, we decided to change it to a tree magically in the middle. All right, what angle did the top of the pole make with the ground, okay? So the top of the pole is right here, and here's the ground, so we're looking at this angle measure. Okay, so that's going to be our theta. So you can use practically any of the functions, right? Which one would you guys prefer to use? You want to do inverse tangent? Okay. Most people did sine all day long, but we'll do tangent. So he's recognizing we have to do inverse tangent since we're looking for the angle measure. Okay, if we're doing tangent, this is going to be the opposite side length, and this is going to be the adjacent side length. And that's the hypotenuse. So opposite over adjacent is going to be 4 over 3. And when you type that in the calculator, what do you get for the angle measure? 53 degrees. You will get the same value if you did sine or if you did cosine. Any of those would work on this one since we have 3 pretty side lengths to be able to choose from. Okay? All right, so last example, number 7. It says Stephen is tying a tent down so that it will not blow away. He will attach a rope to the top of the tent. Okay, so here's my tent. He's attaching a rope to the top of the tent, and he's bringing it out here and he's staking it down. Okay. Now it says if the tent is 5 feet tall, so here we go, the tent right here is 5 feet tall, and he knows the rope is 12 feet. How far should he place the stake away from the tent in order for the rope to be long enough? Okay. Do Pythagorean theorem. Excellent. So 5 squared plus x squared is equal to 12 squared, keeping in mind that 12 is going to be the hypotenuse. Okay, that's going to be our C value in the Pythagorean theorem. So what do you end up getting for the x value here? 10.909. What are the units? Feet. Excellent. All right. Next part says, what angle did the rope make with the ground? Okay, so here's the rope. Here's the ground. So we're looking for this angle measure. So that's going to be our theta. Okay, now again, I wouldn't use the side length. I would use the two nice pretty ones that were given. So that's going to mean this is opposite and this is hypotenuse. So which trig function should I use? Inverse sine. Very good, inverse sine. So opposite over hypotenuse is going to be 5 over 12. And what do you get when you type that in the calculator? And round that to the nearest degree, and it gives you 25 degrees. All right, that finishes up our notes. As always, if you have questions, feel free to see your teacher in tutoring, and I hope you guys have a great day.